Hi, welcome back to Earth Science with Mrs. Miller. We're looking at Chapter 10, Plate Tectonics, and this is Section 10.2, Seafloor Spreading. Now, today what we're going to be focusing on is explaining seafloor spreading, recognizing how age and magnetic clues support the idea of seafloor spreading, and the vocabulary that we want to be on the lookout for is, of course, seafloor spreading. Now, why is this important? The idea is important simply because the seafloor spreading helps to explain continental drift, and it actually changes it a little bit more. So that's a very important topic that we need to be focusing on. And off to the next page. So war is a big motivator. And up until World War I, the seafloor was simply measured by dropping a rope down to the bottom of the seafloor to see how deep the water was. So this was effective, but didn't give you much information. Now, during World War I and World War II, we developed submarines and sonar. Sonar uses sound waves. So in the 1940s and 50s, they actually began to chart the ocean floor. And what they discovered is there were these things called mid-oceanic ridges. Basically, they're underwater mountains. Now, in the 1960s, a Princeton professor, Harry Hess, came along and he gave the idea of seafloor spreading. Now, this was to help explain how these underwater mountains became to exist. Now, what he said is that seafloor spreading comprised of four separate components. One, the hot, less dense material beneath the Earth's surface rises up at these mid-oceanic ridges, or this magma. It heads up during these mid-oceanic ridges. Okay? It also flows sideways. Now, what that means is that it pushes the seafloor away from the ridge in both directions equally. Now, as the seafloor spreads, magma flows up through the crack and becomes solid, forming a new seafloor. But this magma also cools, and as it cools, the denser, heavier material sinks, causing these ridges, these up and down motions. If we go back to this page, you can actually see, if I blow this picture up a little bit, how these ridges actually occur. Now, if you look right here at this dark area, you're going to notice that that's a valley, and that's where the denser material has sunk. In the higher peaks are where that lighter, dense material was. So if we put that picture back, and we're going to go back on. So he needed some supporting evidence, and what we came up with the Glomar Challenger in 1968. Now, the Glomar Challenger was an expedition ship, and it was equipped with a rock drilling rig. And they began to do some drilling and some sampling, and they found, to their surprise, that the youngest rocks were at the center of this mid-oceanic ridge. Now, they also developed some ideas of heat vents, where the heat from the internal Earth was escaping. Now, where they once thought that there was no life in this deep, dark ocean, they are now finding giant clams, mussels, and tube worms. Tube worms being this picture right here. They also discovered something else. They discovered something called magnetic reversals. And how they did that is that the rocks that they found have a high concentration of iron. Now, this rock is called magnetite. And the magnetite is magnetized. We learned about that in last chapter. In chapter 9. And magnetic fields usually enter through the South Pole and exit on the North Pole. And we use something called a magnometer to measure this. But they found out that there are periods of reversal where, and actually what we would think would be South Pole is actually the North Pole. So we have some reversals here. Now, these discoveries showed that many times during the Earth's history, that flow of energy has changed. Now, this isn't a sudden overnight thing. It changes over thousands or millions of years. So if you take this picture and we make it a little bit bigger here, you're going to see where these reversals are occurring. Now, also, I want you to take note that this newest crust is at the ridge, and that the oldest crust is further out. And we're going to learn more about this word lithosphere a little bit later. Now, seafloor spreading helps to account for how the continents were able to move because it's pushing things someplace else. But let's take a break and do a quick listening check. So, in our listening check, and you want to write your answers in your journal, we want to know what properties of iron-bearing materials or minerals on the seafloor support the idea of seafloor spreading. We also want to know how the ages of rocks on the seafloor support that idea. We want to know how did Harry Hess explain seafloor movement, and why did some of the parts of molten lava move towards the Earth's surface, and how is seafloor spreading different from continental drift? Okay, take a break, do what you gotta do, take your notes, and we'll see you back on next lesson.